Welcome, students. I'm sorry that I wasn't able to post a video yesterday. So what I'll say today in this video is that we're only going over one section, one dash two, line segments and distance. So we are actually kind of ahead of schedule because normally today would be 1-1. So what we're going to do in this 1-2 is really just focus on some key definitions and then solving distance formula. So you guys are more confident with distance formula, but in geometry, it's actually understanding these key definitions that helps us do better. So one of the key things is a line segment. Now, a line segment obviously is the line, and it has two endpoints. So in this case, let's call this A and B. Now, the thing in math and even algebra 1 is that there's something called betweenness. Now, betweenness, if you have a number, let's say two numbers. One, so when we do this along the number line, right, there is always going to be a number between two other numbers. And you can actually keep getting smaller and smaller. So there's this number, n. So in this, same thing in the line segment, there is always a point between two other points. So you can never get 2 points close enough that there's no point between them. There is always going to be a point. So that is called the betweenness of points. Namely, that there is always a point n between two endpoints on a line segment, point A and point B. Okay, so point M in our key concept between these two points, point M is between P and Q if and only if. So let's write this out. Basically, what we're getting is we have, let's say, a line segment, and you have P and Q. There is a point M between them if and only if PM, so the length PM, plus MQ equals PQ. That is, if you add up the lengths, they must equal the total length, okay? So this is another way of saying, basically, that these two segments need to add up to be equal to total, otherwise that's not true statement, okay? If you have questions about that, please feel free to ask it. So we're going to go over example 1. Now the key point with example 1 is the units. Units matters extremely greatly. It matters greatly when in geometry we're drawing a line, and we label it, for example, inches. Okay, that inch can be here. But then if that changes from inch to mile, you're talking about an entirely different thing. So you need to be careful when calculating it that you use units. In fact, on the homework, if you use the wrong units, that would just be marked completely off, like in this homework, okay? So make sure you use the proper units in this homework, okay? So example 2, we have EF and FG, and we're trying to find EG. So we're trying to find the total. So EF is 2 3/4. This is the EF, and FG is 2 3/4. We're trying to find EG. So 2 plus 2, that's 4, plus 3/4 plus 3/4, 6/4. So technically this is 4 plus 6/4. Which, if you do the math, this becomes 1 2/4. So we get 5 2/4, which you always need to simplify. So simplifying this, we get 5 1/2. Okay. So I just added the 2's, add the 3/4. You can do it a different way. Obviously, you could write it all as mixed numbers. So that would be what, 8/11/4 plus 11/4. You get 22/4. Doing the math, we get 5 2/4, 5 1/2. Now, Am I done? No, because these units. Okay? This is our key definition. Okay? Key term. Units. You guys know them. We've worked with them. Let's make sure we keep it. Okay. So in this one, we're finding AB. So we don't know AB, but we do know BC. So using AB and using BC, using AC and using BC, we get AB plus BC equals AC. To solve for AB, we get AB equals AC minus BC. So let's plug it in. So then AB equals, with AC, 13.2, with BC, 5.8. Doing the math right here, we get, so this is 7.4, and in this case, this is meters. Okay, notice that meters does not have a period after it, so you do not need a period. Okay, so AB equals 7.4. Now let's try the guided practice. I'm going to give you, you can pause the video here for 5 seconds, and solve for JL. Okay? Okay, if you didn't pause the video while I'm moving on, and so JK plus KL, so just kidding, plus Kuala Lumpur equals Jalan. So JK 8.4, KL 3.9, and that equals, so this is 11, so 12.3, and what units is it? Centimeters, okay? And that is our beautiful answer, okay? You guys can do 1B, but know that you're doing something similar to what we did before. Okay, example 2. So we have enough time, I think, to get through example 2 here, and possibly even talk about equal or congruent. Okay, so x, find the value of a, and xy, if y is between x and z. Okay, so they show us the diagram right here. We can open this up, yeah. So they show us the diagram right here. So 3a plus 14 equals 5a minus 4. So, doing the math, so we have that's a, xz equals xy plus yz, yz. So xy is 5a minus 14 equals 3a plus 14. Sorry. That would produce an answer that is impossible. Okay. Okay, so let's do the math here. I'm just going to move the 3a over, so we get 2a minus 4 equals 14. Add 4 to both sides. We get 2a equals 18. That means a equals 9. Now, do we have units? No. So again, in example 2, do we have units? No. So you do not have to label the units. So the only time you don't use units is when they're not given. Okay? Now you can do the guide practice if you want, but let's move to congruent. So key term is equal and congruent. And I would make notes of this, okay? Equal is about number, okay? Slash length. So, two numbers are equal, two numbers are not congruent. Congruent implies size, the same size and shape. And shape, okay? So equal does not require the same shape. Congruent does. So if I create a line, this line, AB, and I have another line, let's use a straight edge. So I create same equal line, or same congruent line, okay? And I do this, okay? And I say BC. So in this case, A, B, and congruent looks like this. It looks like an equal and a little squiggly, okay? And this is the line segment AB is congruent to the line segment. Sorry, this should be BC. Let's call it CD. CD. The line segment CD. Okay? Now, if you want to say lengths are equal, this is equal. Okay? This is length. Okay? This is line segment. Okay? Slash congruent. And this is equal. Okay? Okay, make sure you know the difference. Okay? We're going to move on to the next example. Okay?